Hi, my name is Silfvernagel, and today I'm going to be talking about machine learning in the browser using TensorFlow.js. But before I start, I would like just to give some background information about myself. So my background is I've been working for 10 years with human-machine interfaces for process automation and robotics, and I've also been working 10 years as a consultant. I have a master's degree in electrical engineering and a master's degree in behavioral science. I'm also interested in artificial intelligence and the Internet of Things, so I've taken some classes at MIT. I have a Microsoft MVP award within AI, and I'm also part of two meetups, the Oslo AI meetup and the Norwegian.net user group. But before we start with TensorFlow.js, I'm just going to touch a little bit upon what machine learning actually is. So a formal definition of machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So this is actually from the very start of machine learning and AI back in the 1950s. But we can also say that machine learning is pattern recognition from historical data. So some applications of machine learning is prediction. You can, for example, do a prediction of house prices based on historical prices, or you can make recommendation. You can build a recommendation engine, so you can recommend products that a customer should buy based on products that he bought historically. You can make clustering to cluster customers, for example, into customer groups. You can make image recognition or text recognition or speech recognition. So one of the way that we can do machine learning is called supervised learning. And here we take historical input and historical output and we build a model. So then we can use this model and we can train it so that we then can make use of other data, of real-time data, for example, and then we can get recommendation out from our model. So some enabling technologies for machine learning is sensor technologies. So now we have cheap sensors that can transmit data rapidly. And we also have big data solutions so that we can store this data and we can transform it and manipulate it. And we have machine learning algorithms that are running in the clouds so that we can use it. And we have API and services that we as software developers can make use of. So some of the two most common languages for machine learning is R and Python. So R is historically more geared towards people from a mathematical or statistical background, whereas Python is more for people who are coming from a computer science background. And one of these libraries that we can use is called scikit-learn. So scikit-learn supports both supervised and unsupervised learning, and it builds upon something called SciPy. And it supports parameter tuning, feature selection, and cross-validation. So now I'm going to give you a quick demo here of scikit-learn. So in this demo, we will be importing a dataset from scikit-learn. And we also need to import something called metrics so that we can evaluate our algorithm. And then we're going to import our classifier. So we're going to use a decision tree classifier. And then I think I spelled it wrong here. So like that. So the first thing that we want to do is we need to load the data set that we're going to use. So we're going to use a data set called Iris, which deals with flowers. So this is a standardized data set that you can read about, but basically it has to do with some of the different qualities of flowers and how you can predict a flower based on these type of qualities. So now we're loading the iris dataset, and then next is we want to fit a model to this data. This is a CART model, which is short for a classification and regression trees model. So we generate a decision tree classifier. Then after that we run model.fit on the data set. And on the target. And then after that we can just print our model. So now we have our decision tree classifier model, and we can see some properties of that model. And then next we will make some predictions. So we run model.predict on this data set data. And now we can summarize how the model has performed. So then we can see our confusion matrix here down in the slide there. So that's just a quick example on how we can use scikit-learn. So then let me get back to the presentation. This. So then the next thing is, what is TensorFlow? So TensorFlow is an open source library developed by the Google Brain team, and it has algorithms that can deal with tensor operations. And tensors, that they are multidimensional matrices that we can use to represent our data. And the big thing with TensorFlow is that it supports distributed computing. So what is actually a tensor? So tensor is a term from mathematics. So we can differentiate between a scalar, which belongs to the real-time numbers, and the vector, which is a collection of numbers, or a matrix, which is like a two-dimensional vector, and a tensor, which is a multi-dimensional matrix. Now with TensorFlow, this is an example of how we can use TensorFlow in Python. So we import the TensorFlow as TF, and then we start a TensorFlow session. And here we define two numbers, 10 and 32, and then we can do session.run to add these two numbers together. But then what is TensorFlow.js? So TensorFlow.js is a JavaScript library for training and deploying models in the browser and also on Node.js. So the way that we can do this is we can import existing models into TensorFlow.js. So we can convert an existing Keras model in H5 model to the TensorFlow.js layers format. And we can do that from the command line So we run a command, TensorFlow.js converter, and then we define our input format, which is in this case is keras, and then we need to define the path to our model h5 file, and then the path to where we want to have the output or converted model to. So in Python we can save a keras model using the code that you can see here on the slide. And then in our JavaScript application we can import TensorFlow.js, and then we can just do an await of TensorFlow load layers model, and then we need to point it to where we have this TensorFlow.js model in our JavaScript application. So the question is, why would we want to run TensorFlow as a JavaScript application? And there are a couple of reasons for that. One is that you don't need to learn another language. You don't need to learn these two languages that I talked about before, Python and R. And that's a huge benefit for people who are working as web developers. They don't need to go into learning these languages. They can just continue using the language, the JavaScript language that they already know. And the second reason is that you don't need any round trip between the client and server. And then the user's data is also local. You do all the computation on the device. So that's a higher degree of security. And also when you use the browser, it's highly interactive and it's easy to use. So you can make a great application with high usability. You can also have easy access to the sensors, to the webcam, and to the microphone on the device. And you can also take advantage of the GPU. So the way this works is either you can run existing models that you have, or that there is a number of existing models that you can import into your project that we will have a look at quite soon. Or you can retrain existing models, or you can develop machine learning with JavaScript. So these are some of the models that already exist. These are from image classification, for object detection, for body segmentation, and so on. So all of these you can just make use of. So now I'm going to show you an example application here. So let me switch here to the browser. So in this example here, we're going to do a prediction of an image. So we will first select a file. And then after that, we can select here a model. We are using a predefined model called MobileNet, and then we're running predict. So now we can see here that this model gives back that it's 99.9% probability that this is a strawberry. So now let's have a look at the code, how this application has been done. So let me switch over to Visual Studio Code. So this is a Node project here. So we're using Express, and we are actually having a library here called static, where we have our user interface here with some labels and some buttons. But I think the most important thing is here that we importing both a JavaScript class here called predict that we're using to do the image prediction, and we are also using something called ImageNet classes that are being used to convert the prediction from a number to text. So I'm going to show you how that is done. So here is the image selector. So basically we're just reading the image that we selected in by using the file reader, and then after that we are selecting our model. So in this case we selected the mobile net. And then we load this model. So here we can see we're using this this function that I was talking about, the load layers model. So then we're using, we go to a library called TensorFlow.js models, and then we call mobilenet, and then to model.json. And if we look at our file structure, then that is here. So here we're going to TensorFlow.js models and to the mobilenet, and this is a mobile net library that I've converted as I showed you before. So these are in form of some binary files here and also model.json. And then when we click on the predict button, it loads this model, and then it does some pre-processing on the image, and then it does model predict. So it creates a tensor of this image, so we get it into the right format, and then it does model.predict on the tensor, and then it will display the 5 top predictions from that model. So that's basically how it is done. So so what this example shows you is that you can make use of a predefined model, and that you can use JavaScript, and that it's not terribly complicated to actually make this type of application. And now let me switch back over to the PowerPoint slide. So now I want to give you some examples here of how TensorFlow.js has been used in some real-world examples. So one real-world example is from Uber. So Uber, they have used TensorFlow.js to make use of a visual debugging tool for machine learning applications that is called Manifold. So you can read more about it on this link. And another example is from Airbnb. So when you're using Airbnb, you need to provide your ID. So instead of sending an image of your ID over to a server, you can make this on the device instead. So what is that does is it identifies that it actually is a proper document, that it is driver's license or a passport, and that can also alert if there is some sort of sensitive information in the picture. And the third example is something called Magenta. So Magenta is a tool where you can use machine learning for music generation. So you can read more about Magenta on the link below. Then I have some references, so you can read more about TensorFlow on the link here. And there's also a great introduction course from Coursera called Introduction to TensorFlow. And if you want to know more about this image classification example, you can see a video series here from Deep Lizard. So with that, I want to thank you for your attention, and you can reach me either on Twitter or you can send me an email. So thank you so much.